project we have done for the ISM 6562 Big Data for Business course. Our project is a prediction of attendance at a baseball stadium using Spark ML. Our data set has around 2,500 rows of data about a particular match that is going to happen at a stadium and the previous match that was played earlier between the same teams. Our dataset captured information about attendance at the previous game, previous host team's errors runs their hits, and previous away team's errors runs hits, whether the previous game was played at night or during the day, and whether the current game is to be, going to happen at night or during the day. Also, we captured also it has data about whether the game was played on a weekend or a weekday. Similarly, about the current game, whether it is going to happen on a weekend or a weekday. There is data about duration of the previous game and also data about whether the home team won the previous game or not. Using this data, we are going to predict whether using this data, we are going to predict whether the attendance at the stadium for a particular match will be less than 3,000 or less than 30,000 or greater than 30,000. This is a binary classification problem, and we use the following four models to build. So we build the following four models. So using these algorithms. So decision tree, binary classifier, logistic regression, random forest classifier, and linear support vector machine. So what we have done is we have taken the data, we have processed it, trained the models and evaluated the models, analyzed the results of this model. So the first model which we have done is the decision tree, and so for the decision tree, what we have did is we have just so first we loaded the data into the Databricks and using PySpark we developed this, and we passed our data and we have done some pre-processing like using the string indexer for all the categorical variables, and then we made the data into vector, and we split the data into 80-20 ratio, and we use the decision tree. So for the decision tree, our target variables is attendance binary. So attendance binary. So this just has in it predicts whether the attendance at our match will be either less than 30,000 or greater than 30,000. If it is less than 30,000, it will be false 0. If it is greater than 30,000, 1 true. So we use the decision tree classifier, and we got the uh, result with the accurate when we evaluated our decision tree, we got the result accuracy as 81%. So just a minute. So we got the result as 81%. So we evaluated the result later and
explain why we took the logistic regression model. It is because it's basically to understand the relationship between the dependent variables and one or more independent variables by estimating probabilities, and this type of analysis can help us to predict the likelihood of the event which can happen or not. And one more thing is this logistic regression model is a great tool for binary and as well as categorical data to estimate effects and make predictions. Now let's go through the model what we have created. So initially uh, I have used the seed for the train, and while splitting the data, why we have used seed is because we want to get the same accuracy again and again while running the code. So which was said before, and this is the code. We have imported the logistic regression, we have created a model and pipe, we did the fit of train model and we got the results. And from we have used the multi-classification evaluator. By that we got the accuracy, we have calculated the accuracy, we got the accuracy as 84.19%, which is the second best of what we used. And we also you did a confusion matrix for cost benefit analysis. Now let me explain why we have used the random forest, because it can perform both regression as well as the classification tasks. It can produce good predictions that can easily understand, and it's also a high accuracy model. And one more important feature of this random forest algorithm, that it can handle the data set that is having continuous variables in case of regression and categorical variables in case of classification. So it performs better results for classification problems. And this is the code which we use for the random forest. It is almost similar as the above one. And as I said, the seed is set at a particular number to achieve the continuous accuracy, like precision accuracy. Each and every time we run the code, we did a model, and we have piped we have only use the indexer, like only categorical variables which we used indexer. These are only five variables which we used in the pipe, and we included the assembler. In assembler, apart from these categorical variables, we also have the non-categorical columns. And we fit the model and obtain the results by using the classification evaluator. We got the results as 85.23%. This is the highest which we got after using four different models. And for further,
Hi, Professor. This is Sai Maruti when I company. Now I will be continuing with the linear SVC model. Uh, Initially, we have started with the logistic regression decision tree and random forest. We got accuracy around 80 to 85%. We are considering accuracy as a measure to evaluate our models, because our data set is pretty much balanced, because we have 51% of positive cases and 14% of negative cases. So this is our we have done SVC model. So initially I have used assembler to combine the categorical variables along with the continuous variables. Then I have used scalar function so that our linear SVC model performs well on the training data. Then I have trained linear SVC on the trained data, and I have transformed on the test data. This is how we got the results. Like we got accuracy around 83.99%, and this is the confusion matrix. We got true positives around 177 and true negatives around 227. So if we compare with the false positives and false negatives, I think these are some good figures. And then we have done some cost analysis on how our four models are performing. So this is our cost analysis. Like our positive is like attendance more than 30,000, and our negative is like less when the stadium attendance is less than or equal to 30,000. So for every true positive case, we have considered the net profit made by like stadium by attracting more sponsors or planning logistics currency. We estimated these costs based on the total revenue, average total revenue obtained by for each baseball game. These are not exact values, but we did some research, and we came up with these values. And for true negative, we have considered this is the profit that can be made by reducing expenses. And for false positive, this is the loss incurred, like 1 million would be the loss incurred by either stadium due to wrong information given to sponsors, and the sponsors to compensate back sponsors. It would average the average cost would be like 1 million. So what we have done was we have taken all the four models and the confusion matrix along with it, and we have calculated TPR accuracy precision as well. And then we have calculated total positive, true positive revenue, true negative savings, false positive cost, and false negative cost. And we have summed them up, and we got the total net revenue. And as we could see, Random Forest has performed very well, both on accuracy and precision, and also on the net revenue as well. It has got the highest revenue when compared with other models. And uh, and and next to that, we have got more profits with linear SVC.
And